I'm done on the mic, ma'am. यार ऑडियो में कनेक्ट आ
Zero பண்ணிருக்கேன். இதை கீழே வைக்கிறேன். இது Yeah. Can you hear me?
Yes, ma'am. Yes, ma'am.
The video is now live on YouTube. Whatever we are speaking, it's recorded in YouTube.
Okay.
At exactly at 4 o'clock, we will start.
ரெக்கார்ட் பண்ணுவேன். இப்போ பண்ணாலும் வராது. பண்ணி பாருங்க.
It will come, ma'am.
வரல.
Yeah, yes, ma'am. You are in waiting room. Just 4 o'clock only is starting. So we are setting up the YouTube live. So we are taking it because your name is already showing for us. Yeah, you can wait. No issues. Within 2 minutes we will. Thanks.
Rafi? Rafi?
Yes, ma'am.
You can hear me, right?
Yeah, yes, ma'am. Loud and clear.
So we wait for 4 o'clock?
Yes, ma'am. Till 4 o'clock.
5 minutes more.
Yeah, yes, ma'am.
Okay.
Ma'am, can you adjust your camera a little bit, ma'am?
Yeah.
Hey.
Can you see me?
Yeah, yes, ma'am. Clear.
Gallery view போட்டுமா? Gallery view. என்னமா? Gallery view. போடலாம். Seventeen people are waiting, 18 people.
அவர் பண்ணுவார். Hello, Prema ma'am, Shrikant sir, all of you, good evening.
Glad to have you back.
Nice to see you, ma'am. Hi, Prema.
Hi. All of us, so glad to have you back again this weekend.
I know. And good evening to Shrikant sir also.
Shrikant is unmute. She can't unmute.
You can't unmute, is it?
No, he is.
Yeah, can you hear me now?
Yes, I can.
Yeah, good evening, good evening.
Good evening, good evening. Looks as though he's the background.
Yeah, he's sitting near the dining hall with the background of the hills.
Because the light is at the back and can't see his face.
Yes.
Okay, so I can turn around a little bit if you like.
You turn around, show your face a little bit.
We have to see your face, Shrikant.
You sit this side of the table. Now
That's it.
Okay, you can see my face now?
Yeah, yes, of course. Otherwise, it was looking like a ghost.
I know.
So, anyway, long looked forward to, right?
Right. Very, yes.
For so many years, you have been inviting me. Never
Exactly.
been able to come.
Exactly.
Will you start?
Yeah, I think we can.
Give us a cue when to start.
There are several people still waiting
I
in the
know.
waiting room. They admitted.
Rafi, can we start?
No, we'll wait.
We are admitting people now.
20 people waiting in the waiting room, ma'am.
He's admitting people.
Yes, he's admitting people.
27, 28 people are waiting.
We are live and we are admitted everyone. The meeting has started.
3 people are waiting. Okay.
Meeting has started, ma.
Okay.
Shall I go with introduction?
Yes, ma'am. Go ahead.
Okay. Welcome to another evening of mathematics and art. We had one last weekend, having the junior school program for the junior school math teachers. Now we are having for the middle school math teachers. And we have with us Saroja Sundarajan, whom I introduced even last week, but she is doing her workshop today. And she is a veteran teacher educator and has been teaching, including teacher training, and has worked in many schools with a career span of almost 50 years. She's authored many textbooks.
Hello.
Which
are from class 1 to 8. She was the first one to be awarded the CBSE Teacher National Award, Best Teacher Award, by President Zail Singh in 1986. These are not just one of her great accomplishments in her career as a math teacher, spanning you have 5 decades. She has also made about 100 creative worksheets with mathematics and art, and this she has uploaded in her website, and the proceeds of which she is contributing to the PM Cares Fund. She has, of course, had many workshops in her bag, and at the age of 85, she's very active still, wanting to do more in the field of mathematics, especially mathematics for teachers teaching mathematics for children. Welcome you, ma'am. Welcome, Saroja, for this meeting this evening, and we are all awaiting to listen to your workshop today. I think you can go ahead now. Thank you.
Thank you very much, Prema, for your kind words. Actually, this workshop is long overdue. I was supposed to have come to your school long ago.
Yeah.
But the opportunity has come only right now. And we had to have a virtual workshop now, unfortunately. I would have enjoyed it in person, maybe sometime later.
Oh.
So we will start the workshop now. Thanks a lot, Shrikant. Shrikant, in fact, Mohammed Rafi, I owe a lot to him. He's been hand-holding me for the technology part. And day before yesterday, when we had really panicked because the video was not working, only the audio was working. And we really gave him a tough time. For about 2 hours, we had to struggle to make it work. And then finally, here we are. And I hope I'm keeping my fingers crossed that everything should go off smoothly today. So I think we should start right now. I'm going to share the screen. Those of you who are present here, I would like to tell you one thing that I'm sure you have all been muted. I would like any interaction in between the workshop, but after the workshop is over, maybe through the chat box or whatever, you can interact with me. I can assign about 5 to 10 minutes for any interaction later. And when the workshop is going on, if there is anything that I would like you to quickly do, you can do it on a scribble pad and get back to me. And if you raise your hands, maybe Rafi will unmute you and then you can interact with me. But otherwise, you're all muted and we go ahead with the workshop. Now,
The mode, ma'am.
okay, now, actually, the CBSE had mandated that art should be integrated with the curriculum, every subject with the curriculum. And this particular integration was proposed by the CBSE in 2005. I'm surprised that after 2005, it has gone through an incubation period of 15 years now. And only last year, NCERT came up with a publication actually showing samples of how one could integrate the subjects with art in the curriculum. But now I think it is now catching up, and several people are now dealing with art and art in the subjects. And I was interested in integrating art with mathematics in the curriculum. So there are several, all the subjects that are integrated here. You will see that art with mathematics, art with social science. You can see Varli art, which Meena had shown the last time that she had done her workshop, and then art with language and art with science. So I'm going to take up art with mathematics. And when I'm talking about arts, there are two types of arts that come to my mind. One is the visual art, where you do a lot of coloring, drawing, painting, cutting, pasting, and so on. And the performing art, where you have the drama, storytelling, music, and so on. Of course, I'm going to give you a glimpse of each, but my main focus will be on art and mathematics. So here we are. We start off with the first slide and visual art with fractals. Now, a fractal is where any object has its part identically the same as the parent. Now you'll see here the Christmas tree. You've all seen the Christmas tree, where this is not actually the Christmas tree, it's a branch of a Christmas tree. Every branch of the Christmas tree is like the parent tree. Every stem of the branch is like a branch and like the Christmas tree. So where the part is actually and identically same as the whole, that is where we call it fractals. It comes from the word fracture. Okay, so there are several fractals in nature. Here we have this famous Sierpinski triangle, an equilateral triangle, where the midpoints are joined to form another equilateral triangle, and the remaining three equilateral triangles also, they are formed, and you keep on getting equilateral triangles, smaller and smaller and smaller, goes on to infinity. So this Sierpinski triangle is also a classic example of fractal art. Now you will see a fractal tree. Every branch of it is like the original tree. But the most famous of all would be the snowflakes as a fractal. In fact, I had actually included snowflakes in animation, but unfortunately, it did not accept it, and the whole thing was crashing. So I had to delete it. Snowflakes, when they are exhibiting their fractal nature, look so beautiful. So these are all fractals where it's a visual art, and you can see in nature how mathematics expresses itself. Now the next one is again a visual art, carrying on over to fractal dimensions. The fingerprints. Now fingerprints are extensively used in forensic sciences to find out and locate the criminal in any criminal case or in a murder case or in a theft case. But the most wonderful part of it is, even though there are billions of people in the world, everyone's fingerprint is different from everyone else's. There are mainly three types of fingerprints: the loop, the wall, and the arch. You can see each one of them is a fractal because it keeps on increasing, but it's exactly like the original one. So this is also a fractal. And these fingerprints, no two are ever the same. And that is the reason why it's easy to use this in forensic sciences to locate the criminal. In fact, here's a little joke saying that a man and a woman holding hand with each other say, I've never met anyone quite like you, because they are so different from each other. Now, to use this as art, you'll see how children love to dabble with color and paint and so on, and how fingerprints are used in art here. You see the trees here so beautifully done by children. And this is also one way of using fingerprints with art. Now, we go on to the next one. All of you must have heard of or seen or heard puppet shows as well as hand shadows. Especially in rural areas, this is pretty common. What they do is they use puppet shows to have, put up shows for the village people, where invariably they take up social issues like dowry or rape or any health issues, and then show it in this form of hand shadows. But here, what I'm going to show you is using the same hand shadows to teach mathematics. Here you'll see here, there's a hand shadow, the hand shadow of a duck's face. Now here, the hand shadow is increased twice its size. You can see here at the bottom, there are 3 squares, and here there are 6 squares. So it is twice its size. So in the ratio 1:2. So you can teach children, they'll really be interested because they are seeing it in the form of a shadow and they think it is drama. So they get interested, and it is in their memory, they'll never ever forget how to think about ratios. So this is increasing ratio 1:2. Look at this bird shadow. Here you have a 2:1 ratio and it diminishes in size. Here you have a 6 and you have a 3, so it is half its size. Now here you have hand shadows as 1:2 or 2:1, and this is how ratio is taught through hand shadow art. Now the question is, in a classroom or anywhere, how do you use these hand shadows? A hand shadow falls on the wall when the light is behind the hand, like for example here. The light falls on the hand, produces a shadow. Now the question is, if you want a hand shadow to be increased in size or decreased in size, then what do we do? Do we hold the hand nearer the wall or further away from the wall? That is the big question. So you will have to determine, you have to tell the children to experiment whether you want a bigger shadow or a smaller shadow, and that is how ratios are taught through hand shadow art. It is a fascinating means of teaching, and I'm sure anyone who has tried it would have tried it with great success in the classroom. So this is, of course, you can call it a part of performing art, but I'm not really taking up performing art in its real sense. Now, here, the next one is now, this is the most important thing I'm coming to. Whereas now, so far, we have seen visual art or performing art. But when I took up a project on art and mathematics, it somehow didn't satisfy me to take the usual route. I never go on a path which is already trodden. So I would like to do something very different. Then I thought to myself, why not take up mathematical skills and consider it as art here, mainly with shapes and numbers. Now, when I'm talking about mathematical skills, here you will see I'm going to list the various skills. Now, when we're teaching mathematics in class, actually, as any good teacher would teach the content, no doubt, but then the content is only a tool to teach mathematics. What you have to eventually think of is developing skills in children, mathematical skills. So I was thinking to myself, why not give it a different treatment, the art a different treatment? Look at it from mathematics itself as art, because supposing, for example, the first skill that I'm taking is to be able to recognize patterns in shapes and numbers. That itself is an art. Not everyone will be able to do that, because you can walk by and not even look at shapes and look at the patterns, leave alone recognizing and then appreciating. It's an art that you have to develop. Not everyone can do that. So I thought, let us list down all these skills and see if these skills themselves can be treated as art. And as we go on, you'll understand how I'm going to do it. Now here, appreciating patterns and shapes is also a big skill. And then we start with a very auspicious presentation, the column. Now in South India, almost all houses, we have columns drawn at the entrance. And then many of them are drawn with number of dots. Now here, I would like to tell you something. This is a real art, column, drawing columns. I have a servant maid who's absolutely illiterate, who does not know numbers, who cannot read numbers, but still she's an expert in drawing dot columns. So that means that art is in her. So let us see here how we have these columns. Now we have got two columns here, one here and one here. The one at the center is missing. Now you can see mathematics in this column. Can you see the pattern here? I hope you'll be able to recognize what the pattern is here. 1, 3, 3, 1. These are odd numbers, 1, 3, 3, 1, and they have been turned into a beautiful column as an art. The center one is missing, and we have the third one as 1, 3, 5, 7, 7, 5, 3, 1. That's the third one. So you can easily, if you have an eye for art, an eye for numbers, you can easily guess what the middle one is. We have 1, 3 here, 1, 3 here, and a 5, 7, 7, 5. But here we have 5, 7, 7, 5. So what's the missing number? So you will have to see what the missing number is. Apart from being, having these odd numbers here, they're also called palindromes. Now, a palindrome is something that when you read from left to right or right to left, it reads the same. Here you have 1, 3, 3, 1. Read from right to left is also 1, 3, 3, 1. Similarly, 1, 3, 5, 7, 7, 5, 3, 1, 1, 3, 5, 7, and 7, 5, 3, 1. These are called palindromes. Palindromes are beauty. Here you can have A, B, B, R, A, D, A, C, and the middle letter is C. Abracadabra. That is a very famous palindrome. Now here you have, again, we're coming back to the columns. So we are going to find out what the middle column is. You have all of these as odd numbers, all of these as odd numbers. So we are going to have only the odd number here. Let us see what the middle column is. We're going to show you a solution. Whoever wants to do it in your scribble pad and draw is welcome to do it. Here you have the 1, 3, 3, 1 first, and then the middle column here, which is 1, 3, 5, 5, 3, 1. How many of you have guessed it right? If you have guessed it right, that is great. And the third one is 1, 3, 5, 7, 7, 5, 3, 1. Now here you will see here, this column, I've spinned it here, and then you will see, and what I'm going to tell you now, which is even more interesting than the column itself. How I'm going to integrate it with mathematics. Now you'll see here, whenever you are, when children go to the higher classes, I think it's in standard 11, that they learn a lot of concepts. Some of the first consecutive odd numbers. Now here we have used odd numbers, right? So look at this pattern here. 1 is 1, it can be expressed as 1 square. Then you have 1 plus 3, which is 4, which can be expressed as 2 square. 1 plus 3 plus 5, which is 9, which can be expressed as 3 square. 1 plus 3 plus 5 plus 7 equal to 16, which can be expressed as 4 square. So therefore you have consecutive odd numbers starting with 1, they are added and they result in a square number. Now the question is, how are we going to connect this with the columns that we have done so far? The columns had all odd numbers, as I've got here, 1, 3, 5, and 7. And they all had, they looked like a triangle, but then look how it's going to become a square. So when you turn it around, you'll see those columns have become squares. Now here, for example, I'll show you here. The 1, 3, 3, 7 is here. 1, 3, 5, 7, 7, 5, 3, 1 diagonally. When it's turned around, it shows a pattern as a square. Same here, and this one also. Here you will see they've all become squares now. See how beautifully it relates to the sum of the first consecutive odd numbers. Here you've seen the odd numbers adding up to a square number. Here you've seen odd numbers expressed as a column. When turned around, becomes a square number. So it's a beautiful integration of art with mathematics. So actually, I mean, these are things that you have to really, in your 1331, 135531, and so on. Every time you look around for patterns. When you recognize them, and then you start appreciating. See, the half the bridge is crossed when you have learned how to recognize patterns and appreciate them. Then you'll really start loving mathematics. We go on to the next topic, which is magic squares. Now here, I'm sure most of you would know what these magic squares are. Here is a 3 by 3 magic square. The numbers 1 to 9 are filled in inside the boxes in such a manner that every row, every column, and both the diagonals, they all add to the same sum. 8 plus 1 is 9 plus 6 is 15. 3 plus 5 is 8 plus 7 is 15. Here it's 15, here is 15, and then again the diagonals are also 15. This 15 is called a magic sum. So every magic square will have a magic sum. This is the very basic, simple 3 by 3 magic square. Okay, it's called magic square because it's like magic, especially for children. Now, the construction of a magic square is very, very interesting. We won't delve into that now, but because we are going to use it for some other purpose, integrating it with art. This might seem a little mundane and boring because we are having only numbers here. But what is coming now is going to be of interest to all of you. Just watch very carefully. Now this is a 3 by 3 magic square, and then the 3 by 3 magic square is drawn again as a 2 by 2 square. Now I'm going to draw a 2 by 2 square. Okay. Here this magic square had 9 boxes. This 2 by 2 square doesn't have 9 boxes. It has got only 4 boxes, but it has got 9 nodes. You'll see here 1, 2, 3, 4, 5, 6, 7, 8, 9. You've got 9 nodes instead of 9 boxes here. Now what I'm going to do is transfer all these numbers inside the boxes to all these nodes here, which are at the vertices of these squares. Okay, so here they have come. Well, the most interesting part will soon follow. You'll see how beautifully art is integrated with magic square here. Now, in this particular square, where the nodes are, we have all the numbers 1 to 9. Now, what we're going to do is join the numbers in sequence starting from 1, then 2, 3, 4, 5, 6, 7, 8, 9, and then go back to 1. Now, I want you to look carefully to see how it is animated. You won't believe I spent nearly about 8 to 9 hours figuring out how this animation should take place and how it should be smooth. And at last, when I discovered how to do it, I was really thrilled and top of the heaven. Just watch very carefully. 4, 5, 6, 7, 8, 9, and back to 1. So it is an animated one where the lines are drawn in sequence. A still more fascinating one is to follow here. You'll see here, I mean, the lines are here, but it's a little difficult for you to find out how symmetrically drawn these lines are. You can see here, I mean, there are several shapes inside this. There are quadrilaterals, there are squares, there are triangles, and so on. But the symmetry is not so clearly seen here. To make the symmetry seen clearly, I've also discovered another animation for it. And you look here at the animation, you'll be surprised what a beautiful symmetrical figure has ensued here. You'll see here how beautiful it is. So what was a drab 3 by 3 square has now become a beautiful, colorful, again, a piece of symmetry. Now we have integrated art with mathematics, and the numbers which were inside the boxes are on the nodes now. They have been joined, and symmetrically, like for example, you have a black here, a violet here and a violet here, a green here and a green here, yellow here, and then you have orange and pink and so on. They're all symmetrically colored. All symmetrical shapes have been identically colored. Well, we are not, I keep a lot of surprises for you, because earlier we dealt with only numbers. Now we have shown you how to color symmetrically these shapes. Now you're going to have something else which is even going to be more exciting. Now here I'm going to transfer the art piece that we have drawn there, 816, 357 and 492. Now what we're going to do is, children can be asked to draw this on a piece of paper and then rotate it 90 degrees and then draw that again. What is 816 here on top has come here, 816 when you rotate it through 90 degrees. Then again rotate it through 90 degrees and you'll find the 816 on the right side has become 816 at the bottom. Then again for the final time, you again rotate through 90 degrees and the 816 has come to the left. So you have 4 pieces of this particular symmetrical magic square here, and they have all been rotated through 90 degrees period. Now, what we are going to do is the children can be asked to draw this and cut out, and then we are going to paste them on a piece of paper. Look at this. 1. This is 2. This is 3. And this is 4. See how beautiful this is. This is a magnified symmetrical figure of these 4 small figures that we have. How beautifully the symmetry has come out, and this is a real good piece of art. But here I would like to bring in a little more mathematics here. You'll see here on the nodes when we did it, the distance between 8 and 1 is the same as the distance between 1 and 6. So that means this side has been divided in the ratio 1:1. And then we had an absolutely symmetrical figure here because it's a midpoint everywhere. So there was absolutely no problem at all. But then why don't you use your creativity in changing these ratios? That's what came to my mind, that I said, all right, let me try out some other ratio. Now this is really a very good thing. So we are going on to the next one, where we are going to try out another ratio to produce an equally kind of a symmetrical figure. Now here, let us take a ratio 1:2. You remember 1 was the midpoint. Now 1 is no longer the midpoint. The ratio is here 1 and then 2. So the ratio is 1:2 here on one side. On this side, it's 1:1. Then you have 2:1. Then you have 1:1. So this is the ratio of the magic square that we are going to use now. And then we've actually shrunk the symmetry. And then the old symmetry has become like this figure as 1:2. So we have this ratio as 1:2. This is my own creation. I was thinking, let me experiment with this and see what kind of a different symmetrical figure we get. So once again, it has to be turned right, 90 degrees right each time. Here we have a horizontal rectangle, and here we have a vertical rectangle. Once again, we turn it through 90 degrees, again back again to the horizontal rectangle. But you see here, these two are different. We have the dark green here at the bottom, because it's turned through 180 degrees, the dark green has come to the top. Then once again, we turn it through 90 degrees, and then we get the vertical rectangle. Just as we did earlier, we're going to draw them, cut them out, and then paste them on a separate piece of paper to see what a symmetrical figure we get. So this one is pasted here, horizontal rectangle, and then this one is pasted here, which is through 90 degrees turned, and the third one is pasted here, and the fourth one is pasted here. You see here, because these are not squares, they are not flushing in with each other perfectly. You can see a small little gap here. That itself is beautiful. Still, the symmetry is maintained. You can see the dark green here, symmetrically placed, the maroons very symmetrically placed, the reds symmetrically placed, and so on. So even with the 1:2 ratio, we still have a symmetrical figure, but it's a little different, that's all. Now, what you must do in your class when you're using this, teachers, what you should do is ask them to use their own creativity and let them use their own ratios. It could be 1:3, it could be 1:4, it could be 2:3, whatever it is, let each one bring a different kind of a symmetrical figure. What you would have done is you would have created interest in them and then sparked off their creativity. So that would be really very satisfying for you as a teacher to see how the children have produced such wonderful art. Now, the next thing is, what we are going to do is, we are going to show you a video, which is really fantastic. It's a very simple video, but it is a fantastic one. I mean, I was very, very happy with this because it's come out very well thanks to my dear friend Meena, who actually took the photograph, the video, and then we put it together, and thanks to Rafi, who had edited it for me, it's come out beautifully. Now you'll see the video and listen to the audio also.
You're going to see a very interesting activity with mirrors here. These are two plastic mirrors taped at the back here and joined so that we can see the images inside the mirrors. These mirrors are placed on a sheet of paper just above a line that I have drawn here. Now you'll see here, I'm going to keep changing the angle. Now as I keep changing the angle, the straight line is becoming a triangle first, and then it becomes a polygon and so on. Now let's see how the change happens. Now as we decrease the angle between the mirrors, the number of sides keep increasing. Do you all see that? What was a triangle first has now become a square. And between the mirrors, you can see an almost 90 degrees angle, which means the angle at the center of a square is 90 degrees. Now, again, you keep on changing the angle, decreasing the angle between the mirrors. The square has become a pentagon. The pentagon becomes a hexagon. The hexagon becomes a septagon. And then it becomes an octagon, then a nonagon, a decagon, and so on. So as you keep changing the angle between the mirrors, the polygon also changes. Now, this is a very interesting activity for children at this age. They know how to really appreciate how the polygons are formed, and they need not know anything else right now, because in the later classes, they're going to learn how the angle at the center is going to determine the number of sides of a polygon, and they will learn about it later. But now it is just enough for them to admire and appreciate the art behind the forming of polygons between the mirrors.
We're going to see another activity now with mirrors, and it's more or less like the previous one, but you'll have to see how different it is.
Now, this is another interesting activity related to the earlier one that I had showed you on polygons. Now, you will yourself look at the images and then you'll tell me what is the difference between the two. You see here a rose, and the image can be seen into the mirrors. Now, as I keep decreasing the angle between the mirrors, you'll see how the number of images also changes. Now you see here there are 3 images of the rose, and then as I decrease again, you see there are 4 images, and then there are 5, 6, 7, 8, 9, and 10, and so on. You see, as earlier, you can see how the number of images keep changing as I change the angles between the mirrors. Now, can you tell me what is the difference between the two? The earlier one showed the number of sides of a polygon increasing or decreasing according to the angle between the mirrors. Now, the number of images are seen as increasing or decreasing depending on the angle between the mirrors. So, what is the difference between the two? Now, this is a.
You will see here the final activity.
Now, the final activity with mirrors, where you can appreciate patterns in symmetry, leads you on to a very interesting application in real life, which is called the kaleidoscope. Now you'll see here as I'm changing the angle between the mirrors, it has a beautiful kaleidoscopic effect and the images keep increasing and decreasing. So this is the final activity to show you how you can have art in mathematics. And here is the final one on symmetry. Now the final activity.
So you must have enjoyed seeing those activities. They are beautiful classic examples of symmetry with mirrors. I mean, it's a very simple activity, and with just a couple of mirrors taped onto each other, you can produce such wonderful, it's almost like magic, and children would enjoy doing it. So here you will see the vertical line of symmetry in some folk art, how this side is a mirror reflection of the other side. This is art in symmetry. And look at this kaleidoscopic symmetry animation, which is just some fantastic. It's a superb animation where you can see the real kaleidoscopic effect in a mirror. Okay. You saw the one in that activity, which was, I mean, I tried to do it as best as I could, but this is a real classic example. So we have finished the art in symmetry. Patterns really are fascinating, whether patterns in numbers or patterns in shapes. Look, here is a crochet work, beautiful symmetry work done in silk, and that also shows symmetry and art, art with mathematics, definitely. So we go on to the next presentation, which is Fibonacci and art. Now, Fibonacci was a famous Italian mathematician. His name, which is spelled as with double C in Italian, we pronounced as Ch. So it is Fibonacci and art. Fibonacci was an Italian mathematician from the Republic of Pisa, and he was a very talented mathematician. He discovered a number series known as Fibonacci series. Now, this Fibonacci series starts with 1, then you have 1, 2, 3, 4, 3, 5, 8, and so on. These are the numbers which are in the Fibonacci series. Now, how are they got here? You'll see here, the first number 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and so on. So if you add two consecutive numbers, then you get the next number in the Fibonacci series. But so what I have done is I've just added a 0 to be meaningful, because for this one, we need another number. 0 plus 1 is 1. So we have this Fibonacci series. This is a beautiful series, because as we go on in the presentation, you'll understand how beautiful this Fibonacci series is. Now here, how do you see also art in these numbers? We are just going to see. Now here you have Fibonacci and spirographs. Take a graph sheet of paper. First, you mark number 1, which is the first one in a series. Then the second one is 1. When you add 1 and 1, you get 2. Here is a square, which is 2 square. And then you add 2 and 1, which becomes 3. So a square of 3. Then you add 2 plus 3, 5. Then you have a square of 5. Then you add 5 plus 1, 6 plus 2, 8. Then you have a square of 8. And it goes on and on and on. Now, we are going to do a tiny little exercise here. Those of you who have graph sheets, one of your worksheets is this. You can go home and do the spirograph, it's called. You start with the innermost, that is the 1 by 1 square. And then you start there, draw a spiral, and go on to the next one, and next one, and next one. And you will see the spiral will go on forever, infinitely. So this is the spirograph, it is called, the Fibonacci's. And it is, it's amazing how, in the 18th century, he was able to discover this. Not only that, you'll see here, more amusing is this. Here is a pine cone, where you can see the Fibonacci spirals here. Okay, and here is the sunflower. Also, you can see the spirals there. Now, the question is a very intriguing question. The question is, did he first discover the series and then accidentally found these kind of spirals in nature? Or did he see the spirals in nature and was he inspired to discover the series? We do not know. But this is absolutely fascinating that you can find the series not only in nature here amongst these flowers and pine cones and so on, but more is yet to come. You will see here the 1, 1, 2, 3, the spiral here. These numbers go on. Now you have yet another discovery, yet another thing fascinating with the series is this. Now, what we have done is we know how to get the next number in the Fibonacci series, right? Now, he has also discovered what you call the golden ratio. How does the golden ratio emerge? We will have to now find out. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 2 is 1.5. 5 divided by 3 is 1.6. 8 divided by 5 is 1.6. 13 divided by 8 is 1.6 something, and so on and so on. So if you take two consecutive Fibonacci numbers and divide the bigger one by the smaller one, you get the ratio called 1.618, which in Greek is used by the name phi, phi. It's the 21st letter of the Greek alphabet. But what is more amazing is that as you go to the bigger and bigger numbers, they all become almost constantly 1.618. 21, you start with 13, 21 by 13, 34 by 21, next is 55 by 34, and so on and so on and so on. You'll find that the ratio is always 1.618, and that is called the golden ratio. Why it's called the golden ratio, you will soon see. You can do this as a as a homework here, finding out the golden ratio in these Fibonacci numbers. Okay. Now, we will see here. This is, I mean, it's just incredible. You can't even believe that this could be true. Supposing you have a line segment divided into two line segments A and B, and the total length is A plus B, right? So therefore, the ratio A plus, hello? I can hear somebody else talking in. The ratio of the total length A plus B to A is the same as the ratio of A is to B, and that is the golden ratio. You'll see here taking our arm. The distance between the elbow and the wrist and the tip of the finger, this ratio is always 1.618. Not only that, you will see here body parts. They're called divine proportions. You know why they're called divine proportions? Because the same ratio you will see here in several of our body parts. You'll see here, it's absolutely incredible. You won't believe this. Here you will see, here's a body. Of course, I'm talking about normal bodies, not the bodies where, people have physically challenged bodies. Here you will see the ratio between the shoulder and the navel and the knee. This ratio is 1.61. You have another ratio here from the navel up to the tip of your toe and then head up to your navel. The ratio is 1.6. Similarly, you can see all these ratios. Every ratio is 1.6. Isn't it unbelievable? I mean, you can't imagine that in 18th century where science or technology hadn't really improved so much, they still knew that the Fibonacci series is seen in every part of this in nature, on bodies, in nature, in flowers. I mean, it's fantastic. Now, looking at patterns, as I told you here, to be able to recognize patterns itself in numbers or in shapes is an art. Not everyone will be able to do it. And thanks to big mathematicians like Fibonacci, we have this big secret unfolded to us and we are able to appreciate the patterns here in the body parts. It's really, really incredible. We just can't believe it. Now, so we go on to the next one. The golden ratio Mona Lisa. Very famous Mona Lisa, painted by the famous artist. And here also, you see, can you see the spiral? Fibonacci spiral. And here also, every part, this divided by this is 1.6, this divided by this is 1.6, this divided by this is 1.6, this divided by this is 1.6. Everywhere, even in a painting, it's like that. And unless you maintain that ratio, I presume when you do a piece of art, it looks really, distorted, and it doesn't really look very nice. So that is the ratio that has to be preserved, the 1.618 ratio, the golden ratio of Fibonacci. Now from spirographs, we go to spiral art. This, many of you who have had, some years ago, this is about, I would call 20 years ago, spirographs were very, very famous amongst children. They used to make spirographs with 2 plastic circles. Now we can do a spirograph here. Draw a circle. Then mark equally spaced dots on the circumference of the circle. We have 1, 2, 3, 4, 5, and so on. Whatever number you want. Here I have drawn from 1 to 27. Then what I have done is I have joined numbers from 1 to 10, 2 to 11, 3 to 12, and so on, until every point is paired with another point on the circle. Now we have just drawn only straight lines, but then with just straight lines, we've got a curve. Isn't that beautiful? The concept itself is so beautiful that you have recognized that you have a pattern with straight lines producing curves. That is something fantastic. Who had ever discovered that? We don't know. We can make your own, you can make your own spiral curves. What you could do is you have here 1, 2, 3. In sequence, you can have just odd number of dots. You can have even number of dots. You can have, different summing of pairs and so on. So you allow the children to be creative and create their own spiral art. You'll see here, this is a beautiful pendant-like spiral art. And then you can see this, that's also a spiral art. You can see here another spiral art. And then here on the right, I don't know if it is. So here you have actually how you have joined these straight lines. You'll see on this circle. You have dots. Now watch very carefully the animation, how the dots are being joined to get a spiral curve. Okay. So you've joined the lines, and this is also an animation. As I told you earlier, I struggled for a while to get this animation, and when I got it, I was really so thrilled. So this spiral art is also, this curve is produced by straight lines. Look at this. This is also a beautiful spiral art. These are all art pieces which you can really preserve. You can do it with silk strings. You can do it with pin and thread. In fact, they were taught in my school with pin and thread, and children produced beautiful pieces of art. So we have a spiral art which is also patterns with numbers. And we go on to next, polygonal shapes in real life. Now the letters in capitals are the names of the number of sides that the polygon has. We'll see here. Triangle means 3. Quadrilateral means 4. Pentagon means 5. Hexagon means 6. Septagon means 7. Octagon means 8. Nonagon means 9. And decagon means 10. Now, for the little ones, you can have a small activity here. Ask them to make 2 trapezia and a rectangle, and then cut them out. And after you cut them out, you may cut out these shapes and give them 3 copies of each. With these pieces, ask them to make an octagon, showing a stop sign. They have to use their own imagination. How would you make a stop sign? How will you make a tree? How will you make a butterfly? And then you draw and color them. Here you'll see here the octagon, the tree, and the butterfly. with just 2 trapezia and a rectangle. 2 trapezia and a rectangle. So this is how they use their creativity to draw. It's mathematics because they are polygons, and it is art because you're producing shapes. Now they see the beauty of the patterns in nature. They know how to translate that into art. So this is one way of using the polygons. Now we are going to see also some other beautiful ways in which we can implement using these polygons. You see here, all these are polygonal shapes, which I have just used with a simple tool in the Word, and then you make these polygons. They get automatically colored first. If you want, you can change the color also. Like for example, supposing you have access to the computer, you may use the color of your choice, and then this is the tools. And you can see a tool here, which I'm going to use, which is circled in red. Okay. Now, when that tool is used, you can just place your cursor on a point and then keep drawing, say, a star. So when you draw the star, it automatically gets filled up with a default color. If you want to change the color, then you change the color in the toolbox, and then you make it, say, red or orange or whatever it is. Now, this is how you can keep working with polygons, playing with polygons. Children can, if you leave it to the children, they are much more creative than we adults are. You will not believe what amazing patterns they can come up with. And because if you allow them to be uninhibited, they can really produce wonders. Now here I am to show you how we can design a piece of jewelry with just these polygons. Okay. In fact, now in the National Institute of Design, jewelry designing has become a very popular course. So many children now want to opt for that course, jewelry designing, because there is so much of costume jewelry going on. They prefer costume jewelry to real jewelry, not only because it is cheap, but it is because, inexpensive. I would say cheap, inexpensive, but because you can have such beautiful patterns and, to match every dress of yours. So this is how a jewelry is designed, a piece of jewelry is designed, and mathematically designed using these polygons everywhere. You can see this polygon here and this polygon here. All these are polygons. So this is how you recognize patterns, you appreciate patterns, and you make use of patterns to really show them as piece of art. The last presentation here in this particular thing on patterns in numbers and shapes is this here. Now, in a there is a person who's running a tiles factory. Okay. Now, there are tiles factory. He produces tiles only of the triangular shape. You see, this is of a triangular shape, and this is of a triangular shape, and so on. Now, these are triangular numbers. 1 plus 2 is 3. 1 plus 2 plus 3 is 6. These are called triangular numbers. And he is producing tiles for the kitchen now in triangular numbers. Now, they are sold only in triangular numbers. But supposing you want to have a square arrangement, what you choose is you choose 2 triangular numbers, consecutive triangular numbers, and make it into a square number. Like, for example, this 3, if it's placed here as 3, this triangular number now has become a square number because 3 plus 6 is 9. Okay. This one, if it's placed here, 1 plus 3 is 4, it has become a square number. So if you want a square number of tiles, square arrangement of tiles, then you choose 2 consecutive triangular numbers to get a square number of tiles. Now, the particular assignment here is, how are you going to here you will see that these tiles here. Now, supposing you want a 25 square arrangement, which are the 2 triangular numbers that you will choose? And that is the question. So you will leave it to the children, as to which two triangular numbers they will choose. Not only that, these are examples of a kitchen tile. Supposing you want to design tiles for your bedroom or for your drawing room, what kind of pictures will you draw? Okay, these are the two parts of this assignment. First, choose two triangular numbers to get a square number, and then you choose what kind of designs you want to make. So this is how you use patterns in numbers and shapes. Now we go back to the list of skills that we started with. Now the first one was appreciating patterns in shapes and numbers. I told you mathematics itself is art. I need not call it art and mathematics as though they are two different things. They are not. Maths itself is art because you look at art through mathematics. And we've done the first one. Now the second skill is, let us see what the second skill is. The second skill is showing problem solving skills. Now this problem solving skill is also an art. When I'm talking about problem solving skills, it does not mean that you are just solving problems. Problem solving skills would entail how you plan carefully, how you're going to solve a problem in a situation, how you're going to strategize your plannings, and then what are the various steps in those strategies. These are all things that you have to think of when you're talking about problem solving skills. It is an art because not everyone will be able to solve problems with strategies. I mean, you might do it by trial and error and so on, but then really laying out proper strategies and then solving them is really an art. Now we are going to see how we are going to do the problem solving as an art. Here, the first one is geometrical shapes with strips of paper. I mean, I had asked the teacher participants to bring strips of paper with you. I don't know if you brought it, but if you have, then you can try and do it on your own. You're given rectangular strips of paper of two sizes, one a narrow one and one a broad one, and two of each, okay? Now that's all that you've been given. There is no folding, no cutting, no pasting, nothing. Now this is where your creativity will come in, and it's a problem solving situation. The point is, how will you make with just these two strips, with no folding, no cutting, no pasting, how are you going to make a square? How are you going to make a rectangle? How are you going to make a parallelogram and a rhombus? I told you, no folding, no cutting. Now, how are you going to do that? Children would really, now this is a real problem solving situation. As I told you, it is an art. Not everyone can think of the solution directly. You'll have to plan. Now, if there's no folding, I can't fold this to make a square. I can't fold it to make a rectangle. All right. There's no cutting. I can't cut it into a small piece to make it a square or a rectangle. So then what am I going to do? So it is in these kind of situations that you will really have to think of a problem solving skill. And as I told you, it is an art. So now let's see how we are going to make it. Normally, you give 5 minutes in the class for children to think about it. And when they're given a time constraint, I'm sure they will really do it pretty fast. Now here you will see the solution here. You going to make a square, okay? Now take two strips, put them one on top of the other, hold it against the light, and what do you see? A beautiful square, okay? Intersection of two strips of the same width yields a square placed perpendicular to each other. Now a rectangle. Now take a narrow one and a broad one and then hold it against the light. You'll see a beautiful rectangle that is formed because they're of different widths. Now, not only are they able to do this, they're able to apply their knowledge of properties of square and rectangle. They know a square has all sides equal, so they have to choose two papers of the same width. They know a rectangle has different length and width, so they have to choose two of different widths. And they know also if a parallelogram has to be slanting, so they have to place it slantingly on top of another square. And because the sides are not equal, they have to choose two different widths. So this is how, if you hold it against the light, you can see a beautiful parallelogram. Similarly, for a rhombus, all sides are equal, and therefore you take of the same width, hold it against the light, and you'll see a rhombus. So this is a very simple solution. But then, I mean, not everyone can really think about it. It requires an art to think about a solution. And the strategies, as I told you, how will I get a square if I have to have a same width? How will I get a rectangle of different widths and so on? There's an art to be able to think like that. And that's a problem-solving situation where they apply their skills. Okay, so then we go on to the next one, which is art and mensuration. A circular garden is of diameter 14 meters. Here is a circular garden, 14 meters. The problem is you draw 4 semicircular areas symmetrically and aesthetically placed inside as play areas. Now, how will you draw them? That is the point. The point is also one more restriction they have given, that these semicircles are of diameter 7 meters each. Okay, so then here this is it. Now, when this was given to a class of children, they came up with different ideas. I'm sure you can also do it on a scribble pad, the various ways in which you want to place these semicircles, 4 semicircles inside this big circle. Some relationship between the 14 meters diameter and 7 meters diameter should be there. You know what it should be. So therefore, you have all this. How will you draw these semicircles inside a circle? So one such example that first came was this. Now this was totally rejected by me because there are 4 semicircles, of course, but when they're put together, they become a circle. So what difference does it make? You might as well say circles instead of semicircles. They're not disjointed. So this was straight away rejected. Okay. Then the second one was this. This looks really ugly. It is not aesthetically appealing. So this was also rejected. Now the third one was this. What would you think of this? I mean, this is okay because it follows the rules that they are symmetrically placed. Okay, I mean, aesthetically not so great, but it's possible. But then you have the final one as this, which is aesthetically very pleasing and symmetrically placed. And you see, because this is 7 meters, it is half the diameter of the circle and so beautifully placed. So out of the 4, this one was the one which was accepted. But here you see the problem solving skills again. Every time we gave a reason for not accepting this. So if you have to solve a problem, it should be acceptable by whoever we are submitting it to. So therefore, a problem solving skill comes into play and as a piece of art. Now here, dissecting a square. In many workshops, when I have given a A4 size paper to teachers and asked them to fold and tear and get the biggest size square from a rectangle, they have all fumbled. What they have done is they just folded it and then made any square. But that is not the point. The point is you have to get the biggest square. Okay. So then they did not know that the width here should be the side of the square. And therefore, from this corner, if they fold it and it comes here, then it becomes the biggest square. Now, in this context, a group of children were given this particular exercise of showing how you can divide a square into 2 equal parts. Everyone can do this. I mean, this was most commonly done either diagonally, it's 2 equal parts, diagonally this way, 2 equal parts, horizontally this way, 2 equal parts, and vertically this way, 2 equal parts. But as a teacher, you should not accept the routine ones. You should make them think and think creatively. Don't accept any of these things. Tell them, are there any more ways of actually dividing them into 2 equal parts? So therefore, they will have to now think differently. It's a problem-solving skill, and they should give at least 3 to 4 ideas. Here you have a square paper. Now you have the solution here, 1 big square. Let us see how it's divided into 2 equal parts differently. See, this part is equal to this part. But it's done differently, not in the usual way of folding it into half. Now you see here another example, divided equally. You'll see here another example, divided equally, and another example, divided equally. So all these are examples where you think of dividing something equally in different ways, in creative ways. And doing it something creatively is an expression of art. It's not the routine way in which we do. So the problem solving skills comes there in this. So now we go on to the next one here. The next skill which says exhibiting spatial skills. Okay. Now exhibiting spatial skills is an art. What is spatial skills? Now spatial skills means how you are able to manipulate objects in space. That is what you mean by spatial skills. It's an art. Supposing, for example, you're traveling, you have to pack your bag. You wouldn't just, haphazardly pack your bag. There is a way of doing it so that you economize on space, and at the same time, you see that certain things are not crumpled or broken or something like that. So how you will be able to utilize space very judiciously and carefully. And that is what you call spatial skills. And then again, I'm telling you, the spatial skills requires art. You should not, it's an art of, the way of thinking of it is an art. Now let's see how we are going to do it. This is actually a topic in Standard 8. Nowadays, it's becoming very popular. Here is a 3D structure. Okay, this 3D structure can be viewed in a 2D form. It's called perspective art. Now, when you're calling it perspective art, here it means what is your perspective of that particular 3D. There are 12 views given outside here. What you have to do is you'll have to find out which one of these views corresponds to this particular 3D structure. And this has got 3 views. This is the front view, this is the right side view, and this is the top view. Not only corresponding to this, but also which view is correct, you'll have to find out. Okay. Now I'm going to show you a video, but before that, what I'm going to tell you is how will you, if it's not just a spatial skill that comes in, but here you have a problem solving skill also, you have a logic skill also. All these skills come into play, and everything requires an art to do it. Now here you will see these, you can see how we are going to do it. The bottom row, you have 2 yellows and 1 red. So let us examine all these where there is 2 yellows and 1 red. Here you have a 2 yellows and 1 red, and nowhere else here. Here you have a 2 yellows and 1 red. Okay. You have on the left the 2 yellows and on the right 1 red. Here you have on the right 2 yellows, on the left 1 red. So it can't be this. So by process of elimination, it has to be this. 2 yellows on the left and red on the right. The second row is blue on the left and red on the right. And on the top, a blue. So it fits in beautifully here, and the view is the front view. So that is how the problem is solved. The spatial skills come into play, and the logic skills are also used. So now what we are going to do is, here you'll have to see now. We're going into a video now to tell you how you actually teach the children to be able to see a 3D structure in 2D form. We're going to see that right now.
You just did an activity on problem solving with 3D figures. Now I'm going to show you actually how the 3D figures have to be looked at in order to know how the 2D view looks. Now this is called perspective art. Whatever structure, the 3D structure you have, leave it on the cardboard piece and then look at it at eye level. Especially at eye level with one eye closed, and if you look at it, you'll see beautifully the 3D form in a 2D view. Can you see that? Now you see here, I'm going to show you the 2D view also, which is the front view of that particular structure. The lower level, that is the front row, actually is seen as 2 yellows and 1 red. Even though in actual practice they are on different rows, we see them in the same row in a 2D form. The second row is 1 blue and 1 red, and the third row is just 1 blue. You'll see here, this is actually the 2D form of the 3D structure. Now this is extremely important for architects when they do their plan and elevation, because they will have to really think about how they're going to present a 3D view, 3D structure in a 2D view. Now this structure we will have to look at in 3 different views. One is the front view, and now what we are going to do is we are going to look at the right view. You turn it around and then see the right view. Now when you see the right view, you'll see again, don't forget, just close one eye of yours and then look at it. The 3D will disappear and then you will see only a 2D form. Now this is the 2D form in the right view. You can see the lowest row, you have 2 yellows and 1 red. The second row is 1 blue and 1 red, and the third row is 1 blue. You see, this is the beautiful 2D form of the 3D structure. Totally different. In fact, the perspective art really can deceive your eyes. Now, the third one level is where you see the top view. And remember, the top view always has to be seen from the front view. This is the front view and this is the top view. Now, the top view has 1 yellow in the first row, 1 blue and 1 yellow in the second row, 1 blue, 1 red and another red in the third row. This is the top view. Now all these 3 views together make up the 3D structure. Now if you are given the views and asked to make a 3D structure, you need all 3 views and only then you can make the 3D structure. Even if one of the views is missing, you cannot make the 3D structure. So it's a beautiful form. This is called the perspective art in mathematics. And the perspective is that you are able to see a 3D structure in a 2D form.
So I hope all of you understood 2 important aspects in trying to find out the 3D structure being turned into 2D form. One is you'll have to hold it to the eye level, and the second one is that you will see it with one eye closed. Okay, so therefore here is the solution. This is the particular 2D view, and this one is the front view of that. So we have seen how beautifully the spatial skills and the perspective art are connected. So here, of course, we have, I've just taken a photograph of that, whatever video we saw, and the front view, the right view, and the top view. And since I was not very happy with just a photograph, and thanks to Meena, I had the video done. Okay. Now from 2D to 3D, now we have seen 3D to 2D. We are going to see 2D to 3D, how we are going to create optical illusions. Okay. The first one is you have a box here where these are drawn and then these arcs here are drawn. Now what you're supposed to do is every region you draw these arcs and color alternate regions differently, so that how are you going to do it so that this looks like a 3D figure. Now that's what we are going to do. We have to leave it to the children to think about it creatively and then produce a 3D arc. You see here, just the shape of the arc in a different way has really produced a 3D figure. Now, illusion of a 3D space, like for example here, you have a square and then you have also a cone. How are you going to make them look like 3Ds? Now, you will see here, I'm going to show you just this square. You keep on drawing squares inside. And then finally you will see it's like a room that you're going into corridor to the entrance there outside. So beautifully done, right? And look at this cone. You complete the lower part of the cone in alternate colors and it looks like a 3D cone. So this is how you find an illusion of a 3D. The next one, we're going on to computational skills. Now, computational skills, Vedic mathematics is covered completely with 16 sutras. Now here, I'm going to show you multiplication of 2-digit numbers where they end in 5 and the tens digits are the same. Now you'll see here the first step is to multiply 5 times 5, okay? And 25 comes here. Second one is what you call Ekadika Purvena. Ekadika means one more than. Purvena means the previous. So one more than the previous number, 6 is 7. So you multiply 6 by 7 and you get 42. So you have 4225 as the answer. Okay. So you can try these 45 times 45, 5 times 5 is 25, 4 times 5 is 20 and so on. So this is how you will have multiplication of 2-digit numbers ending in a 5 and the tens digits as the same. But supposing it doesn't end in a 5, the same rule can be applied to numbers that add up to 10, but the tens digits are the same. So you will have as before, 3 times 7 is 21. And then this one 6 times the next number, Ek Adhika Purveda is 42. So you have 4221, you can do it mentally. Now this computational skill is an art. In this connection, I would like to tell you that children will have to develop this art of multiplying, doing computations very fast because it helps them in the long run. So the computational skills here, you will see another application of it. The number codes in your calculator or in your computer, they have codes here. All the digit codes are expressed with just 9 dots. And then you give a small little example, a problem. Express the highest 3-digit number divisible by 5. Now here is 995. Okay. The least 4-digit number that ends with the same digit and is divisible, starts and ends with the same digit and is divisible by 7, 1001. So this is also a computational skill where children are able to quickly find out what the pattern is. Now we go on to the next one. This is a really, really wonderful, story that I'm going to tell you based on Egyptian fractions. This requires a little bit of attention from your part because Egyptian fractions are a little difficult to understand, but you will understand if you pay attention. Egyptians always expressed a fraction with the unit fractions, the sum of unit fractions. Unit fractions means the numerator is 1. So 2/3 is used as 1 by 2 plus 1 by 6. 6 upon 14 is 1 by 3 plus 1 by 11 plus 1 by 231. This is where greedy algorithm is used to find out, express them as unit fractions. Now I'll tell you what the greedy algorithm is and how we do it. Now here, first of all, let us take this example. 6 by 14. 7 by 14 is half, but 6 by 14 is less than half, right? And that is the biggest fraction that we can take out of 6 by 14. So because you're taking the biggest fraction, it is called a greedy algorithm. You're greedy enough to take the biggest fraction. So from 6 by 14, you minus the half, you'll see the next fraction is 1/3. So you get a 2 by 21. Then 2 by 21 is the highest unit fraction. You express it as 1 by 11. So you remove from 2 by 21 by 11, you get 131, 1 by 231. Now here, the 6 by 14 is expressed as the sum of 1 by 3 plus 1 by 11 plus 1 by 231. I'm sorry, I'm rushing through, but this, you don't have to worry about this right at the moment, because what we are going to do is, we are going to really, connect it to a story. Now, this one I'm not going to go through because this one is pretty complicated for you to think and do it. Those of you who have got the worksheet can work on these as worksheets at home. Now, what I am really going to do is we are going on to the next skill, which is that we have finished the demonstrating of the mental computational skills. We're going to story narration and dramatizing skills. This you will find really hilarious and really very, very interesting. Now, this is about the Egyptian tribes. Now, Egyptians in those days, they used to live as small tribes in small groups. Bedouin tribes were a famous tribe, Bedouin. And they had, every tribe would have a chieftain. Now, this chieftain here of this Bedouin tribe went to a battle and he was mortally wounded in that battle, and he came back and was struggling between life and death in his tent. So at that time, he called his favorite friend, Ali the barber, and told him, look, I need help in writing out my will to my 3 sons, because he had only camels those days. Camels were the treasure that they gave their children. So he said, I want to give out my sons, my camels, and in the ratio 1/2, 1/3, and 1/7, because he had 3 sons. So, and he told him, look, I've got only 41 camels. In what ratio will I divide them and give to them? Because 2, 3, and 7, you'll see the LCM is 42. He's got only 41 camels. Now, how is he going to divide this in that ratio, half, 1/3, and 1/7? Now, Ali the barber, all Arabs were supposed to be very good in mathematics. Ali was an extremely intelligent person. He said, don't worry. We will go and borrow 1 camel from your friend, and that will make it 42. Then we'll do the partitioning according to your ratio and return the camel back to him. But then the chieftain said, how is that possible? I can't believe it could be possible. So he said, wait, let us see. Now we are going to use the greedy algorithm. So in that greedy algorithm, there are 42 camels, but the fraction is only 41/42. This is more than half. So which means he'll have to first take the half. Half of 42 is 21. Okay. So he's got, the first son has got 21. So the second son is 1/3 of 42 is 14. Second son has got 14. The third son is 1/3 of 42 is 6. He's got the 6. I mean, the third son has got 6 sons. So the first son gets 21, which is half. Second son gets 14, which is 1/3. And the third son gets 6, which is 1/7. So each one of them have got their share. Okay. Now 1/3 plus 1/7, 1/3, 1/2, this 1/3 plus 1/7 is actually whatever you have with the LCMS 42. The first son now, he's very happy, he's got 21. Second son has got 14, and the third son has got 6, and the total is 41. So still that 1 camel remains, right? So he returns the 42nd camel to the owner, to his friend from whom he had borrowed. So this is over. I mean, it's an interesting story, isn't it? And how they are able to really solve this problem is really very good. But the climax doesn't stop here. Just wait and see. What happens is here, there's a real bombshell. Inside, the chieftain is in his deathbed, almost dying. And suddenly the tent opened and in came rushing a young fellow. He was Mustafa's 3rd son. Even while he was dying, Mustafa gets very angry. He said, Hamid, is this the way to enter the chieftain's tent without permission? So you know what the son says? I apologize, Master Mustafa ibn Mukhtar. Your third wife Fatima has just borne you a son, your 4th son. That was a big bombshell. Because he had planned on giving only to 3 sons, now he's got the 4th son. Now give the problem to your children and ask them how they are going to solve this particular problem using the greedy algorithm to divide them amongst the 4 sons. Okay? So you have a story narration and dramatizing skill is also over. And the last one is creative skills. Creative skills naturally implies that it is art. Now you'll see here, you'll show your creativity by drawing and coloring figures of animals and birds using only triangles. Here you can see, using only triangles, a fish in a marine environment. Here you have a tortoise, and then you have a cobra in a cobbled path. These are all some samples that are given here. And I have recently created a website called mathsfundsindia.com. And in this mathsfundsindia.com, this is one of the worksheets. And at the end of every worksheet, I ask a question Did you find it difficult to constrain yourself to the shape that you had to use for your figures? How did this activity help you, right? So now, this kind of an activity, you used to have these two worksheets, okay, from my website. This is about the tiles that I told you. This is about using attributes, okay? So one of my great grandnieces, she has done these as worksheets, and I was really proud to see that she had done a wonderful job of it. She is a student of PSBB here in Standard A, and she has done a wonderful job of it. So then that is one, and you have also marine creatures using only circles and sectors of circles, and that is also a creative art. And then you have polygons and symmetry. You see here the pencil shavings. How beautifully you can do pieces of art from pencil shavings, the polygons, and then here you teach them rotational symmetry also. So therefore here you have all these creative skills. The mandala art. Mandala means circle. You can give this half of the mandala art to the children, ask them to complete the mandala art. It's basically a Buddhist philosophy, and they have created beautiful symbolic pictures of the universe in terms of art. You can see on the internet such beautiful mandala artwork. Now, coming to the last part of this is technology and art. How they are using technology to design weaving baskets. And it's sometimes really frightening because the way we use technology is changing even what art is now. With the advent of artificial intelligence program, which is essentially a basic software, which learns to write itself and learns and creates art, and that art creates art, we do not know what art is going to be in the future. Really, human creativity has been enhanced by technology, no doubt, but it is a really frightening one. I must show you something here. Day before yesterday, as I was sitting in the drawing room, my son suddenly sent me this on my computer, on my cell phone, and I saw myself being photographed here sitting on a sofa. And then he said, this is done by an app called Google Art and Culture. He had downloaded an app, and then you're clicking on the camera, you get options, and the option is art selfie. Now that art selfie, you can take a photograph and embed it onto any painting of your choice. This is a painting by Van Gogh, and he embedded it onto that. I mean, it is lovely, no doubt, and it is really amazing, but it is frightening also. I mean, what the future holds for us, we really do not know. However, what we can say is art teaches us to imagine, create, and reflect our ideas in a visual representation of the world. There's a lot of symmetry and there's a lot of beautiful art. We learned about the golden ratio also, a perspective art also. Now, all these are really wonderful skills that we have to instill in the children. Of course, I mean, teachers we know have you got the correct answers? Have you followed the rules? Teachers ask the children that also, no doubt. But then we also have to make them appreciate art and make mathematics itself as part of the art. So with this, I finish my presentation, and I thank everyone a lot. In fact, I thank Prema for giving me this opportunity of giving this presentation, and thanks Srikanth also. Now, also here, I want to thank Mohammed Rafi a lot, because he has been doing a lot of hand-holding for myself. But because day before yesterday, what happened was, when we were having a trial run, the video failed and only the audio was heard. I got really scared because this technology you can never trust, and supposing it lets you down in the last minute, what will happen? I was really worried. Thank God everything went off smoothly, and thanks to Rafi, who has really, I mean, done a wonderful job of it. Prema, I thank you very much. Someday I hope I'll be able to visit your school in person and physically, because our relationship has been over 75 years old. I have known Prema as a baby in arms, and her sisters and my sisters, and we have all been classmates, you know, in school. So it's a kind of a 75-year-old relationship, a family relationship. And I'm happy that after a long time, we've been able to establish a relationship with each other. I do hope all of you enjoyed the presentation and have learned how to look at mathematics as art itself and not integrating art with mathematics. Thank you very much.
Thank you very much, Saroja.
It was a pleasure.
I think if people want to ask a few questions.
One more thing, is there anyone who wants to ask any questions? Shall I see, I mean, in the chat box, are there any questions coming up?
Charan, any questions?
The chat box, there aren't any questions, ma'am. I think maybe someone can ask it live if they want to ask.
Excuse me, ma'am.
Yes.
I'm Rama here. So beautifully you have linked mathematics and art. I want to know whether all these are available in the website of yours so that we can take it to the children in the class.
No, all these are not available in the website. Some of them are. The website has 100 creative worksheets, and the 100 worksheets are priced at 1,000 rupees. And whatever money accrues from that goes to the Corona Fund. And
that's okay.
Yes, so I hope you noted down the website ID.
1 second, can you say it again?
Mathfundsindia.com, MATHFUNDS India.com, mathfundsindia.com.
Fundsindia.com.
Yes.
Okay.
So you can access you have a lot of ideas there also, because there are 100 worksheets, and definitely you can get a lot of ideas from that also.
But all these drawings, the art form of mathematics, everything is available there?
Yes, most of them are.
Okay. Okay. Thank you so much. Thank you, ma'am.
Anybody else? Okay.
Ma'am, I'm Kameshwari from Coimbatore.
Yes.
It's an excellent presentation and we have learned a lot from you, ma'am. Thanks a lot for sharing your knowledge and experience with us.
Thank you very much. So, thank you very much, Prema. So,
okay.
Anything else that you would?
Yeah.
Anything else that you would like to say?
No, I just want to thank you immensely for both Meena and you for sharing the 2 weekends for us. And I was thinking as to how in the middle school area with the fractions and all this symmetry, how this art is going to be presented with so much of association with numbers. So I am amazed at the scope of this art math combination. I'm amazed at that. Thank you so much, Saroja. Thank you so much.
In fact, many people were, those who were non-mathematicians were really scared. They said, if we attend the workshop, will we understand? I said, it's very, very general. It's nothing, it's not serious mathematics at all. So therefore, you'll find it quite interesting and easy.
That is true. That is true. Whenever some of us have been brought up with fear of math. So anything connected to math, we have wondering, why will I understand what is going on? But your presentation was excellent. Thank you very much.
Thank
you
lot.
very much. And very practical, very practical.
Excuse me, ma'am. Good evening, ma'am.
Yeah.
I'm Ganimati from Coimbatore.
Mm-hmm.
Ma'am, first of all, I would like to thanks a lot for integrating math with us, because we were wondering how to involve art and maths. The ratios, particularly with the hand shadows, it was nice. When it comes to higher class part, ma'am, till 8th standard, somehow we are managing and we are introducing all such art kind. When it comes to higher classes, can you give some clue, ma'am? How can we go with the art integration in 9, 10, 11, 12?
Though that is a very big area. We'll have, it can't be told to you just now. It's a very big area. Maybe sometime I will try and do that also.
That circle thing, ma'am, for 9th and 10th, you can take that circle, what she showed, the symmetry circle, the lines, that design you can show them. They can do that. Circles.
Also the mensuration.
The mensuration, the polygons. That
Yeah,
is all we can
maybe
do.
the
They can.
storytelling for
Yes,
interest
yeah.
component.
And from this itself, we can develop, ma'am, for higher classes.
Yeah,
Not,
yeah,
Yes.
yes.
not for
ma'am.
level. Yeah.
Lot
That's
more we are taking home, ma'am. Thanks a lot. Thanks a lot.
Thank you very much. The chat I recorded. Chat. Thank you very much, all of you, and thanks, Rafi. Rafi,
Thank you, ma'am.
can
Thank
you
you so
hear
much,
me?
ma'am.
Rafi, can you please send me a copy of the chat?
Sure, ma'am. Sure, we'll send it, ma'am.
Okay then. Thank you very much.
Thank
Can we
you.
leave?
Thank you. Thank you.
Okay, bye.
Bye.